Hello guys, my name is Dylan, my YouTube channel is DRG Bros, and welcome to another video. Today we are going to be doing a review of Calculus 6, Trigonometric Integration 2. So topic 1 is going to be a review. So what we're going to talk about in this review is combinatorics, which systematically counting the number of ways things can happen. So for example 1, we're gonna do two little things. So imagine we have a little box, and inside it we have A, B, and C. So what we're going to try to figure out is how many ways we can take those three letters out and form a different combination. So we have A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. So in total, we have a number of 6 possible ways. Now we can do it this way, but eventually when the numbers get higher and higher, we're not going to be able to do that. So what we have to do is we have to come up with another way. And so what we can find out here is that we have 3 possible options for the first letter. We have A, B, and C. And then for the second letter and the third letter, however, on the second one, we have 2 options to pick. And then the last one is forced. And what we can do is we can multiply these together to equal us 3 factorial. And what the factorial means is, for example, 3 factorial is 3 times 2 times 1. And if we go, say, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So here we would get 6. Now what if we do this? We take our box, and instead of A, B, and C, we have A1, A2, and we go on and on until we get AN. So what we can say here is we have N, and then we can put N minus 1, N minus 2,
Motion detected at front door.
N minus 3, on and on until we get 3, then we get 2, and then we get 1, and then this equals N factorial. In this case would be our answer. So now what we can do is we can move on to example 2, which is, these are called combinations. So what we're gonna have is, we're gonna have 5 numbers. So 1, 2, 3, 4, and 5. And so what we're gonna do is we're gonna try to see how many 3-digit combinations we can make with these swap numbers. So what we're gonna say is 5 choose 3. And so this is equal to 5 factorial over 3 factorial, 5 minus 3 factorial. And so this is then equal to 5 times 4 times 3 times 2 times 1. This is then over 3 times 2 times 1 times 2 times 1. What we can do here is we can say on the top bit we have 5 times 4 times 3 times 2 factorial, and we shave off that 1, over 3 times 2 times 1 times 2, 1. And so, since 2 factorial is 2 times 1, we can essentially cancel these two. The 3's cancel out, and then 4 divided by 2 is 2. So, in all, we have 10. 5 times 2, which is 10, over 1. So 10 divided by 1 is 0. So our answer is there is 10 possible things, like 3-digit codes you can make with these 5 numbers. So now we can move on to topic 2, which is going to be the binomial theorem. So for example, what we're going to say is if we have a plus b cubed. So this is going to equal 3, choose 0. A 3 minus 0, b 0, plus 3, choose 1, a to 3 minus 1, b 1. And then this allows us to get plus 3, choose 2, a 3 minus 2, b 2. And then finally we have plus 3, choose 3, a 3 minus 3, b 3. So what we could do with this is we can say that this is equal to 3 factorial over 0 factorial, and then 3 factorial. And then this is a 3. And then we can say plus 3 factorial over 1 factorial, 3 minus 1 factorial, a to b. And then this is added to 3 factorial over 2 factorial, 3 minus 2 factorial. And then we add, of course, a, b2. And finally, this is equal to 3 factorial over 3 factorial, 3 minus 3 factorial, b3. And then what we can do is we could substitute that, giving us 6 over 1, because 0 factorial is equal to 1. And then times 6, a3, plus 6 over 1, 2, times 2, a to b, plus 6 to 1, a b 2 plus 3 or 6 over 6 times 1b3. The next step that what we can do, and the final step of what we can do, is we could say equals a plus b, this is equal to a3 plus 3a squared b plus 3ab squared plus b3. This is our final answer. And now we can move on to topic 3, which is the application for this. What this allows us to do is we can say we have the problem, the integral of sine squared x cosine 7x dx. And so what we always want to do is look for odd powers. So in this case we have the 7 right here, and that allows us to do a special trick. So this is equal to the integral of the sine squared x cosine 6x cosine x dx. Then this allows us to say equals sine squared x cosine sine squared x cubed cosine of x dx. This allows us to get equal to the sine squared x 1 minus sine squared x cubed cosine of x dx. And so this is equal, what we can now do is we can do u substitution. So u is equal to the sine of x. So du over dx is equal to the cosine of x. And then du over dx times dx is equal to the cosine of x dx. Dx's cancel out, giving us du over cosine of x is equal to the cosine of x dx over the cosine of x. We could cancel those out, giving us du over cosine of x is equal to dx. So now that we have that solved, what we can do is we can substitute in u. So this equals the integral of u squared 1 minus u squared to the cubed cosine of x du over cosine of x. These cancel out, giving us only u's with a u squared 1 minus u squared cubed du. So now we can use what we learned in our review and topic 2 to create our solution. So what we say here is that this equals the integral of u squared 3 choose 0 3 choose 0 1 3 minus 0 negative u squared 0 plus 3 choose 1 1 3 minus 1 negative u squared 1 plus 3 choose 2 1 3 minus 2 negative u squared 2 plus finally 3 choose 3 1 3 minus 3 negative u squared cubed. Okay, now that we have this, what we can do is we can say that this is equal to the integral of u squared 3 factorial over 0 factorial 3 minus 0 factorial 1 plus 3 factorial over 1 factorial 3 minus 1 factorial to the negative u squared plus 3 factorial over 2 factorial 3 minus 2 factorial minus u squared plus 3 factorial over 3 factorial 3 minus 3 factorial negative u squared cubed du. So now that we have this, we can convert it like we did in topic 2, giving us equals u squared integral of 6 over 1 times 3 plus 6 over 1 times 2 negative u squared plus 6 over 2 times 1 negative u to the 4th plus 6 times 1 negative u to the 6th du. And now what we can do is we can say that this is equal to the integral of u squared 6 minus 3 u squared plus 3 u to the 4th minus u to the 6th du, of course. And then what we can use with this is this equals the integral of 6u squared minus 3u to the 4th plus 3u to the 6th minus u to the 8th du. And then what we can say with this is that this equals 6 sine of x to the third over 3 minus 3 sine of x to the fifth over 5 plus 3 sine of x to the 7th over 7 minus the sine of x of 9 over 9. And then lastly, to finish the problem off, we're gonna say our final answer is 2 sine 3x minus 3 over 5 sine 5x plus 3 over 7 plus sine 7x minus sine 9 of x over 9. Thank you guys for watching. I hope you enjoyed this video, and I will see you next time. Bye.